find if we have any restrictions on domain. We don't have any restrictions and our domain is equal to all the numbers. We have to find x-intercept and y-intercept. The procedures already seen in class, we find that x is equal to 2 and y is equal to 0. Then we have to find our symmetry. That's we found that it's even. We made the proof. We also made it plus r. We have to find all the vertical and gaps. We don't have any. And then we have to find the horizontal asymptotes, and it doesn't exist.
Hi, now we are going to explain the first derivative and the ID test of our function. First, for the first derivative, we need to have our original function, that is this one, and we do the procedures learned in class to obtain the result as the first derivative, that is going to be this one. In the ID test, we need to our first derivative, we need to put it equal to 0, so we need to solve it for x. In this, we do the procedure to obtain that x is equal to the square root of 2. Now we use this value as the middle of our graph, or in this case a line that is going to be this one. In the middle we put the value that we obtain in the derivative. In the part of the left we use the same value, but we need to subtract just one to do it as a less number in here. So this is going to be the new function, and x is going to be equal to 1. In the other side, in the right side, we need to do the same, but instead of subtracting, we need to add one number. So it's going to be a square root of 3. In this case, we solve with the derivative formula we had in the past, and we put f of the number we obtain in here, so it's f of 1, and we need to do the procedures to obtain a number. In this case, we only use the sign that is going to be negative, and we put it here as we obtain it. Now in the other part we do the same, but instead of f of 1 we use f of a square root of 3, and we're going to get this number, and it's a plus sign that is going to be this one. This means that if we have minus and plus in these sides, we are going to have a graph that is going to start from the minus infinity to the plus infinity. So this is going to give us like the way is going to be the graph. Here we are going to explain the second derivative. In this case we have g of x because it's another function, and it's this one. We do the procedures learned in class as in the first derivative, and we obtain that the result is going to be this one.
I'm going to explain concavity test. First, you have to derive your initial equation. G of x is equal to 4 to x to the 4 minus 4x squared. Get the first derivative and the second derivative. In the second derivative, you equalize it to 0, and you get the interval, the inflection points, that is x is equal to positive square root of 2 over 3 and negative square root of 2 over 3. Here is the interval points. To find the values of the test value, you have to find a number between these 2 points, and I get minus 1, and you will do the same as the other interval points. In the value that you got on the test value, that is minus 1, you substitute in the second derivative, and if you get a positive sign, you write plus, or if you get a negative sign, you wrote minus. And the concavity is that if it is positive, you write a happy face, and if it is negative, a sad face.